Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we continue with Chapter 3, which is the Latex Specification and Testing. Actually, this is the last chapter for PST221. For this chapter, we will cover more on the importance of the testing that you made for latex concentrate and field latex. Usually been covered during laboratory session. So we will go through what is the importance of this testing. So hopefully when you go through this chapter, you should have your lab manual so that you can refer the parameters and the importance of the certain parameters that you will use during the measurement and the calculation itself. Okay, so the lesson outcome for this chapter, at the end of the semester, student must be able to state and explain the latex testing, calculate the value of latex testing, analyze the significance of the latex which related to its properties, justify the relevant standards, natural rubber testing based on the specific properties of the natural rubber latex. And then, okay, for this lesson outcome, actually most of you already achieve it during laboratory session or during your write up your lab reports. Actually, some of the testing did ask about the what we call that the calculation, how you measure certain value, what's the importance of certain parameter that affecting the results of you field latex and concentrated latex. Okay, so 3.1 is latex sampling procedure. Okay, I think I will go through a bit fast about this because I think this is the third time I did mention about the latex sampling procedure. Initially I did mention about this process during the chapter 1, and then we go through with chapter 2. I explain a bit details, and here I think I just do some revisions and some reminder during sampling procedure, latex sampling procedure. So basically, the rubber latex maintain to crimp on standing. Okay, so when during your storage it will start to crimp, so the dry rubber, which is low in molecular weight, will appear on the surface of the water or the serums, and the serums and slush will be at the bottom of the tank. And the latex shall be thoroughly agitated to obtain a homogeneous blend suitable for the withdrawal of a representative sample. This is all the what we call that the standard procedure. If you see my video during handling the what we call that the latex testing, we start with the shaking the latex bottle so that your latex will homogenize when you take a sample for the testing. Okay, in all cases where drawn from several containers, for example 10% sampling of latex in drum, or in the case of tanks, are made at various depths. Such as samples shall be bulked and stirred. Okay, if you have more than one containers, you only take 10% for each of the drums or the containers. If you have a very large tanks, so you take the sample at different depths. For example, you have a latex tower, so that maybe you take in a depth of 1 meter, and then 3 meter, 5 meters, and etc. So each of the different depth you only take approximately 10% sample. Okay, so that you have a more homogeneous sample, and then the final average sample shall then be bulked and stirred, and then whenever you take the few amounts of your latex sampling, and then you mix thoroughly, and it will be your homogeneous sample. Okay, and then we go to the flowchart of latex testing conducted during the production of latex concentrate. Okay, here's it is a very important procedure, and I would say this is the at least the minimal requirement procedure that need to be followed during conducting the latex testing. Okay, we start with the free latex. Okay, when you receive the free latex, the first thing you need to do, you check the DRC, Vfa and Ammonia. So the important of doing this is the first one for the RC, so that you can segregate your latex, which is very low latex, very low the RC numbers of free latex should be separated. It will not be used during latex concentration process, either the certification, creamings, or what do you call that, evaporation. Okay, and then we have Vfa and Ammonia. Ammonia is very important because it is the identification of amounts of ammonia that being added to your latex is significant enough or not, because if it is not well preserved, it will affect the Vfa number, which is the microbial will start to the process, and the Vfa number will increase, and eventually your latex cannot be processed to be produced latex concentrate. Okay, when you have the data of the DRC, Vfa and Ammonia, you might adjust a little bit of the amounts of maybe the ammonia. If you find that the ammonia content significantly low or slightly low, you can add some ammonia before you proceed with the latex concentration process. For example, the certification process, because during the certification process itself, significant amounts of ammonia will be eliminated during the certification, and will left your concentrated latex with less amount of ammonia. So it is very important to add good amount of ammonia during the process, latex concentration process. And then we go to the latex concentrate. When you during the certification process, you produce the latex concentrate, and again you measure the DRC, TSC, magnesium, Vfa and ammonia. Okay, and then you will adjust this value using either the second preservative ammonia or TMTD, zinc oxide, or LATZ. Okay, it is depends on the final product that you want to produce. Okay, or depends on the consumer or your customer, what the product that they want to produce, what's the secondary preservative they want to use, so that it will achieve the final product specification that you want to use. And then as you have the final latex concentrate, you can transport or ships to the customer, and again when customer receive it, okay, they will measure the DRC, TSC, magnesium, viscosity, coagulum, KOH, MST, VFA, pH, and ammonia. All these 10 testing should be conducted when they are receive the latex, so that they can cross-check with the data that you provide earlier. If it is not similar or the difference is huge, so they might discard the latex and may not pay any money to your company. So it is very important to have what we call that, a good data and testing, so that each of your customer can refer it again before you start with the mass production. Okay, 3.2 determinations of total solid content. Okay, TSC. Okay, total solid content. The acronym I use is TSC. But please, when you answering a test, quiz, or final assessment, please don't use the TSC. Please write the full name, the total solid content. Okay. A method for the determination of total solid content of natural rubber latex which contains preservative agent and which has been submitted to some types of concentrate process. The principle of TSC is latex dry sheet is weighed before and after heating at either 70 degrees Celsius plus minus 2 degrees Celsius, or at 100 degrees Celsius plus minus 2 degrees Celsius until the sample lost its whiteness for either 16 hours if you use 70 degrees Celsius or 2 hours if you use 100 degrees Celsius. So the principle is very I think very simple and straightforward. So you just wet the dry sheets, okay, to make sure that the sheets you produce is properly dry. So you can use either 70 degrees Celsius or 100 degrees Celsius. So when you have your dry sheets, you may put your dry sheets in a desiccator for a while before you measure the dry latex. The significance of this determination of TSC, it indicates the concentration of latex including the DRC and non-rubber content. Please remember, the TSC and DRC determination almost similar, but the difference is over here. If TSC, you measure the DRC and non-rubber content. For DRC, you only measure the DRC content itself. Okay, after that we go through the DRC. So I think you will have a general idea what I mentioned earlier. Okay, the calculation of TSC is very simple. The total solid content is expressed as the percentage of mass as follow. So the TSC equivalent to the mass of the dry sheet. Okay, the dry sheet that you prepare. You dry in the oven at 70 degrees Celsius or 100 degrees Celsius for 16 or 2 hours, and then you divide it with the mass of the test portion, the initial weights of your liquid latex, okay, and then times 100, so you get your TSC value. Okay, usually high or low TSC or DRC content are due to the sampling error. Okay, so sometimes usually I will ask students to do replicates for this testing, so that you have you try to minimize the error during sampling. So if you do some 3 to 5 sampling for each of the latex, so probably you can discard 1 or 2 values, so that you will have a good value of TSC. Okay, it is essential that latex is thoroughly homogenized before sampling. This is I keep remind students, where when you do sampling, you take sample, please shake your sample bottle thoroughly before you take the latex sample for testing. What happens if you are not make your latex homogenized? If it is not done, sample taken from the top will give high results, those from bottom have low results. Why? Okay, usually it's as I mentioned earlier, the DRC's rubber content have a lower molecular weight as compared to your serum. So during storage, so there is a separation between the serum and dry rubber. So if you take sample on the tops of the bottle, you will pick significant amounts of rubber, so it will lead to higher values of TSC. Okay, if you take the bottom samples, so you will have a low value of TSC. That is why I did mention the point over here. It says that high or low TSC or the RC content are due to the sampling error. Usually you will not have too high or too low values of TSC and DRC. Usually they are almost similar, only slightly different. Okay, we go through the second testing, which is the determination of dry rubber content or DRC. Okay, a method for determination of DRC of NR latex which contain preservative agent and which has been submitted to some types of concentration process. The significance of DRC is to measure the actual rubber content from the latex. Then the chemical can be added based on DRC value. If you remember, okay, most of the testing rely on the DRC or TSC value that you measured earlier. So it is very important to do a TSC and DRC determination very accurately, because you will use this data to measure the amount of preservative, the amount of acids to be added into your free latex or concentrated latex. Okay, so the calculation of the RC is almost similar with TSC. The dry rubber content is expressed as the percentage of mass as follows: mass of the dry sheet divided by the test portion times 100. Okay. Previously I did I think in our labs, or our video that I prepared for laboratory, we did cover two methods of the RC. The first one is the spot method. Okay, although it's not very accurate, but it will give you the rough idea of your DRC values. Okay, and the most common use is the standard method of DRC and the most accurate. Okay, so this one is also covered. So spot method and standard method. The third method, which is the Metrolike Latex meter, that I haven't covered because we don't have a latex meter. But don't worry, in this chapter I will elaborate how the latex meter function and how we measure the DRC. Okay, so determination of DRC by spot method. Okay, basically okay, I did mention about this. Determination of the RC by this method can be carried out rapidly and with reasonable accuracy. So it's not as accurate as a standard method, but you can use it as a rough idea the amount of the RC in a free latex or the concentrated latex. Okay, the procedure, I think I go through very fast this procedure because you I assume you already go through with my video that shows how we conduct the spot methods for the RC. You weight accurately the empty petri dish and record the weight for 4 decimal points. You add 2 to 3 drops of the latex into empty petri dish and weight accurately, and make sure that these 2 to 3 drops at one point so that they touch to each other. So I don't want it to be separated. Okay. And then calculate the latex by pouring the 5% of acetic alcohol solution, which is we prepare the 5% of acetic with 95% of ethyl alcohol alongside of the petri dish until the latex is rounded and covered with the acetic alcohol. Usually we don't put the acetic alcohol direct to your latex drops, so you put at the sides of the latex drop so that it will eventually merge to your latex and it will coagulate. So allow the latex to coagulate and flatten the coagulant by pressing with flat bottom glass stopper. I think glass or silicone rubber stopper should be okay, or stainless steel block, ensuring the no folding and tearing. So you need to press it very gently, but make sure it is flattened enough. Okay, we don't want a very thick sample because we try to avoid any water content. Pour off the acid mixture and rinse the sample with clean water, and then the dry sample over steam bath for 15 minutes until a clear sample is obtained and free from undried spot. Wipe the outer portion of the petri dish with a piece of dry and clean cloth. Place sample in the oven at 100 degrees Celsius for about 5 minutes or 70 degrees Celsius for 30 minutes. And then you take out your sample, cool the sample in desiccator for 5 minutes and weight the petri dish with the rubber for 4 decimal place. Okay, and then your determination should be carried out in duplicate. So the duplication is to minimize the error so that you have a better results. Okay, enough for that spot method. Very simple, very straightforward. And then this one is Metrolike. Okay, Metrolike might probably a new method for you to measure the RC. Why the RC have so many methods of determination, because DRC is very important. The first part is DRC determine the values of rubber itself, so that the amount of you pay actually depends on the total amount of DRC. Okay, the DRC determination of latex using a Metrolike depend on the principle of hydrometric measurements of a specific gravity of latex. Okay, so you know that latex in liquid solution, okay, hydro, so that it will use this hydrometric measurement features at a specific gravity of latex. I will mention later on. Okay, this is one of the fastest and direct methods of measuring the RC of latex. Okay, among all of three methods, Metrolike is the fastest. Okay, even faster than spot method. Okay, reading taken from the Metrolike may be erroneous under the following conditions, such as, okay, latex from young seedling trees, and unstable latex, or latex with some added preservative. So usually Metrolike can only measure with latex which is from the matured tree. Okay, you must have a stable latex, or we call that no preservative other than ammonia. Usually this is very important so that you can have very accurate readings of Metrolike. In any circumstance, the hygrometer will behave abnormally. So what happens if the latex is not suitable during the measurement? The hygrometer will start to fluctuate on the surface of latex, or it will start to rotate it. Okay, so if this occur during the measurement, you need to go with other method, which is a spot method or the standard method. Okay, the procedures of latex stometer. Okay, you take 2 pints of water, add in 1 pinch of well-stirred fill latex in a gallon measure. Okay, so ambil dua bahagian air, 1 bahagian fill latex. Okay, campur kedua dalam unit gallons lah. You mix thoroughly the diluted latex and then pour into aluminium jar in a coagulating pan until the latex overflow. So you need to have what we call that, the latex with smooth surface. Okay, you remove any foams on the surface of latex and allow the material to sink into a diluted latex slowly. So you put the latex stometer in a mixture of latex with water that you prepared earlier. You allow it to sink. Okay, allow the material to rest without touching the base of on the sides of the jar, so you can adjust your latex stometer so that it will not standing on the sides of your jar. Make sure either at the centers or at least it's not resting on your jar. Okay, take the reading on the stems of base of the meniscus of latex. So at the latex stometer you will have stem reading. So you measure the reading, takes the reading, verifying the reading by pushing the Metrolike down lightly and not the reading. So after you take a reading, you try to push latex stometer or Metrolike gently and lightly, and you release it. Do it multiple times and take a reading every time you do that, because we want to try to have very accurate measurements of what we call that, the stems on the meniscus. Okay, the calculation. The reading of Metrolike stem shows, for example, 115 gram per liter. And then how to calculate the DRC? So 115 times 3. Why 3? Because you take 2 pints of water and 1 pinch of latex. Okay, so you times 3. Okay, divide by 1000 because 1000 equals to 1 liter. Okay, time 100, so you get the percentage of DRC 34.5. But it's not stopped until there. Okay, take a look at the down here. There is a rule that you need to remember. If the RC between 35 to 40%, you will deduct the value with 10% of the total value. If the DRC below than 35, you will deduct 5% of the DRC value. So for example, this one 115 times 3 divided by 1000 times 100 equivalent to 34.5. The value is less than 35, so you will deduct 5% of the 35. Okay, your 35.5 deduct by 1.73. Sorry, you minus. Okay, 35.5 minus 1.73, you will get the 32.8%. This is the DRC value measurement using the Metrolike latex stometer. Okay, but there is a note: if low DRC latex should only be diluted 1 by 1 with water and multiplying the reading with 4. Okay, so what happened here? The measurement of the Metrolike over here will times by 2. Okay, but the reading will times by another 2, so it will be 4. Okay, or you can simply times 4 divided by 1000 times 100, and you will have a reading, and this reading also apply to this rules. Either it's 35 to 40% or below 35%. Okay, I think the measurement of Metrolike usually covered in test or final exams. So make sure you go through the simple equation, do some past equation. I think you will get used to it. Yeah. Determination of DRC for skim latex, I think nothing much to worry about this. You can go through how it measure. Okay. And then the determination of alkalinity. The principle of alkalinity, latex is stirred to pH 6 in the presence of stabilizer, and its alkalinity is calculated from the quantity of acid which is required. The titration is carried out electromechanically or alternatively with meter indicator. So for alkalinity, actually we do conduct two methods, which is the standard and the spots alkalinity. So the significance of this measurement, the ammonia content can be used as indication of latex whether it is well preserved or not. High alkalinity indicate latex is well preserved, or vice versa. So usually it depends on what type of preservation that you use. Sometimes you will use the high ammonia content, so you need to know how high is high ammonia. Sometimes you use the LA, the low ammonia preservation system. So how low is low the ammonia? So you need to know the amounts of ammonia still within the range of the preservation that you use. Okay, the low alkalinity are usually due to the loss of ammonia to the vent in tanks or drum. That's why usually we will keep on measure the latex what we call via the schedule. So that when although initially you measure the latex ammonia of the in the latex is stable enough for high ammonia content, but maybe after 24 hours, okay, or 48 hours, you need to remeasure it again, because the ammonia might evaporate and the amounts of ammonia will reduce significantly. If this happens, bacterial infection should be prevented because it may lead to the coagulation of latex. If you keep on schedule measurements of your latex preservation, you will avoid the bacterial infection or bacterial growth. It is very important. It will affect on the Vfa number. Next is the determination of mechanical stability time. Please refer these notes, and at the same time you may pause after each of the determination or the testing. You go through again with the video that I prepared during the conducting the laboratory testing on the latex, the concentrated latex. You will have a better understanding if you do so. Okay, the principle: latex is stirred at high speed and at the time required initiating the mechanical stability. So The significance of this testing, the MST is a number of seconds of stirring required for the formation of the flocculum as seen in a drop of latex into a petri dish containing a water, which is the shelf life of latex. The endpoint of the first appearance of flocculum must be more than 160 a second. So if your appearance of flocculum below than 160%, that's 650 seconds, okay, most probably it's not a good stability MST for your latex. You need to figure out how you need to stir your latex during preparations of the latex compounds before you produce a final product, okay, or else it might the small flocculum may affect on the if you do the dipping product, it will pick up what we call that non-homogenized of amounts of rubber during the dipping process, so it might affect on the defects of your final products. Okay, next is VFA. Okay, the VFA number is defined as the number of grams of potassium hydroxide which is equivalent to the volatile fatty acid content in 100 grams of total solids. So that's why for VFA number, you use the amounts or the values of TAC that you measured earlier. Okay, the principles: 50 grams of latex is coagulated with ammonia sulfate and the coagulant is removed. 25% of sarin is taken, so you don't pick the rubber but you take the serum. Okay, you acidify with sulfuric acid and you steam distill. Okay, this one you use the Markham still. We did conduct the laboratory video for you, so go through with this video so you have a general idea what I mentioned about the steam distill. Okay, the distillate is aerated with carbon dioxide free air, okay, so that you will remove the carbon dioxide, and the titrate again the barium hydroxide, then with phenolphthalein as indicator. So you put some phenolphthalein and then you titrate barium hydroxide. The titration stops when a pale pink appears, so that you know the amount of barium hydroxide is used during the titration process. So the amount of barium hydroxide will be used as the measurements of the VFA number. The significant higher VFA number indicates an inadequate preservation of NR latex and the destabilization process begins. The addition of preservative is necessary. Okay, VFA is non-reversible process, so it is very important you preserve your latex at early stage to avoid the values of VFA increase significantly. The lower VFA number is better for your production. Next is the KOH number. The KOH is defined as the numbers of grams of potassium hydroxide equivalent to the acid radical combined with ammonia in latex containing 100 grams of solids. Okay, a sample of latex containing 50 grams of solid is taken. Its alkalinity being adjusted to 0.5% of ammonia on the aqueous phase. It is then diluted to about 30% of solid water. Then electrode of pH meter is immersed in the liquid and incremental addition of potassium hydroxide solution made with a constant stirring. So the whole process involves of the stirring. You don't need the very fast stirring process, only very mild but a constant rate of stirring. The pH is recorded after each addition. I think you add 1 ml at one time, and each of the pH during additions of the potassium hydroxide will be measured. The titration endpoint being taken as the points of inflations of the graph of pH against volume of potassium hydroxide solution. The result is found by calculations. Okay, the significance of KOH determination: a high KOH number with a high VFA number indicate inadequate preservation of the latex. Okay, usually the KOH and VFA number indicate the stability of latex. If both of these number is very high, you might want to discard your rubber. You can put some acids to produce a dry rubber, so that you can still use your latex for dry rubber productions. If during the purchasing you receive from the supplier the KOH and Vfa number is very high, you might want to return the latex. Don't accept or don't proceed with any production. It will yield more problem during the process. Okay, that's all from chapter 3. Before I stop, I think there is some wise word from me. Okay, knowledge is like a garden. Okay, if it's not cultivated, it cannot be harvested. So here, what I need to say over here, although we already covered the chapter 3, I think most of knowledge has been transferred to you. You already have the knowledge, but the important here, how you nurture it, how you cultivate it. Okay, once you have a knowledge, you need to take care of it. You need to add some knowledge, continue on reading, do some research. Same goes to the garden. If you want your garden to be beautiful and eventually can be harvested, you need to give them significant amounts of light, fertilizer, water, etc. Same goes to the knowledge. By doing that, eventually you can harvest it, and it will reflect maybe in your result or in your future career itself. Okay, by then it's all from me, and I hope you enjoy in learning of these topics. And if you have a problem, you know how to contact me, and I see you later on. Thank you and goodbye.